supported by the way our semantic memory is organized. The task is consistent with what our representations are like. And what it really measures is language proficiency. The more words you know, the more you will be able to generate. It's a test of proficiency. Ah, well, that's not nice, is it? All right. Oh, yeah, okay, yes. Okay, so I can just go from this one, yeah, okay, thanks. I have no idea what I pressed, but I take full responsibility. All right, so it really is a test of language proficiency. There's a very nice study that came out of University College London recently that showed a correlation between how well people do on this task and the density, gray matter density, in the left inferior temporal gyrus, which is where semantic memory is stored. So it's really clear that this is a vocabulary test based on semantic memory. So bilinguals should produce fewer words, right? You saw those normal distributions overall. Now, the second aspect of verbal fluency is called letter fluency or phonological fluency. You have to name all the words you can that begin with the letter F or the letter A. There's also a lot of restrictions. You can't name proper nouns, you can't name numbers, you can't use variations on the same word. If you say run, you can't say ran. Now, this is a much harder task because that's not how our vocabulary is represented. So you really need a very clear search strategy that includes a lot of monitoring, suppression. This is sounding to you a lot like executive control. You also need to know words. So letter fluency depends on proficiency, of course, but also on executive control. And in that same study by Grogan and colleagues, the areas that are correlated with performance on this task, the pre-SMA and caudate, are areas that are responsible for executive control. So again, nice confirming evidence that this is an executive control task. So bilinguals should overcome their deficit, right? Here's what it looks like in a sort of a picture form. Suppose that this is some kind of a scale where up towards the top it's better performance and down it's worse performance, and that's some kind of overall standard. Now we have equivalent groups of monolinguals and bilinguals matched on everything we can. We give them a category fluency task. Category fluency measures proficiency. Bilinguals have a proficiency deficit, therefore bilinguals should produce fewer words. Now we give them a letter fluency task. Letter fluency measures proficiency plus control. Bilinguals have a control advantage, they should overcome the deficit. So the prediction is that they'll perform equivalently on letter fluency, but worse on category fluency. Here's a study with some 20-year-old monolinguals and bilinguals who are randomly selected from our pool, but cognitively equivalent on all our tests. On the PPVT, the monolinguals outperform the bilinguals. Monolinguals have higher vocabulary. Here are their verbal fluency scores. On category fluency, just as the prediction shows, the monolinguals produce more words, and it's significant. On letter fluency, they're equivalent. All right, that's just what I showed you in that little cartoon model. So if we say that that reduced lexical access comes in part from that representational, shall I say, deficit, I hate to use words like that, that requires control, what if we got rid of the deficit? Now recall that in those normal distributions that I showed you, there was a huge area of overlap where you could find both monolinguals and bilinguals. Let's select our sample then. We'll keep them controlled, so they're matched on cognitive measures, but we're now going to select bilinguals who come from that range under the curve where their PPVT scores are equivalent to monolinguals. So now what are the predictions? For category fluency, their proficiency is equivalent. We expect category fluency to be equivalent. For letter fluency, their proficiency is equivalent. Bilinguals have better control. So now we expect bilinguals to do better than monolinguals. First time ever, folks. Bilinguals should do better than monolinguals on a verbal fluency task if you take care of proficiency levels. So we did that. We added a group of such people whose vocabulary was equivalent to monolinguals. Those are the data I showed you before. And now we add the new group, and this is exactly what we get. The new group of high proficiency bilinguals do category fluency equivalently to monolinguals, but better on letter fluency than everybody else. Okay, the second example I'm going to give you is a metalinguistic example. You know, where this all started was 30 years ago when I started looking at metalinguistic development and stumbled really on some tasks where bilingual children always did better than monolingual children. This is really where it came from. It came from looking at linguistic processing. So a very standard executive metalinguistic task is grammaticality judgment. But when I was starting in those days to play around with different forms of that task, I came across this manipulation, that you could change the context in which the grammaticality judgment is made by making the context more or less misleading, and in that sense, more or less conflicting. We did it a number of times, but then other people did it. So I'm just going to show you a kind of an amalgam so you get an idea of the pattern of results. We asked children to judge sentences and just to tell us if the sentence is said the right way or the wrong way. And by right way and wrong way, we only mean grammatically correct. And we give them lots of examples and lots of training. Apples grow on trees. That's said the right way. And children understand that. And then they would get sentences like this: apples growed on trees. And they have to realize that that's not how you say that. So they learn that. And then we give them sentences like this: apples grow on noses. And it's said the right way. And we give them this whole story. There's a puppet, he has a Band-Aid, he fell down the stairs. But it's okay to be silly, you just have to say things the right way. So, and then you can make both things wrong. So the critical manipulation is that to recognize that apples growed on trees has a grammatical mistake. That's really a test of linguistic knowledge. You have to know that there's something wrong with the language. But to be able to say that apples grow on noses is said the right way, you have to deal with a conflict between form and meaning. It's a metalinguistic judgment, so there's conflict involved. We gave this to children in many experiments, and the results always look like this. The children are the same on all of them except the conflict. So bilingual children, more than monolingual children, are able to ignore the silly meaning. It's like a Stroop test. You have to ignore what's kind of hitting you in the face, but is not correct for this response. We recently gave this task to adults. This study had 16 monolingual, 16 bilingual adults. And we gave them this task while they were having their EEG recorded, which we analyzed in terms of ERPs. I'm not going to do the standard primer on ERP. If the graphs I'm going to show you look ridiculous, just jump over it because it really doesn't matter. I'll tell you what I want you to know about it. So you give them sentences like this: apples grow on noses. Those aren't actually the sentences we gave to adults, but that's the kind of thing. We gave them two kinds of tasks. There's a large grammaticality judgment in the adult literature, and a lot of it uses sentences like this. But in the standard task, which I'm calling the acceptability task, the instruction is to just say if the sentence is okay or if there's something wrong with it. Anything. It doesn't matter what. So anything that's wrong with the sentence requires you to say there's a problem. So when you get a sentence like, apples grow on noses, is that okay? You have to say no. But remember, that's not what we asked children to do in those original studies. We said, I don't care if it's silly, just focus on the grammar. So we added a condition called grammaticality, where we say to the adults, as we had to the children, just tell me it's okay if the grammar is okay. So in that task, apples grow on noses, is that okay? This time you have to say yes, all right? So that's the critical difference. This task, the grammaticality task, presents conflict. Conflict is the cue for the executive control system. So here are those graphs that if these make your head hurt, let me just show you what you need to know. The left column are the ERP waveforms for the acceptability task. The monolinguals are solid lines, the bilinguals are dotted lines, and all you need to know is that there's no difference. So whatever is happening electrophysiologically in the brain between when people are doing the acceptability task, it's exactly the same for monolinguals and bilinguals. There's no conflict, okay? The right-hand column is the grammaticality task. So the same people solving the conflict questions, and now you see there are differences. Not on the correct sentences, when everything's okay, but on the conflict sentences, you can see there's a very different waveform for monolinguals and bilinguals. And I'll just tell you what the waveform difference is. The bilinguals are less thrown off by the conflict, so they have less deflection, smaller amplitude. So they handle the conflict better. It's more natural for them. They're more skilled at it. This also shows you that in the acceptability, these are which side of the brain lights up, and the only difference is that on the grammaticality task, the bilinguals are showing much less overall activity, and they're using both sides of their brain equivalently, unlike the monolinguals. Okay. Now, I've been saying that it's about conflict. How do I know that? I've told you several times that when a bilingual has two languages that they use regularly, they're both activated, and that's the source of the conflict. Now, in that case, you can never really isolate conflict because I've defined it into the bilingual experience. But there's one case where that's not true. There's one situation where highly fluent bilinguals do not necessarily experience conflict. And that is if their two languages are spoken through different modalities. So if you're a bilingual, an English-French bilingual, you cannot say dog and chien at the same time. So something has to give. But if you are a speech-sign bilingual, you can and do produce both. So work by Karen Emery has shown that speech-sign bilinguals do this all the time. They just produce both. So you just take away the conflict problem because There's no jam up in the channel. So we did this study a few years ago where we had monolinguals, bilinguals, and speech sign bimodal bilinguals. And they did a little flanker task where it doesn't matter, it's like a Stroop task. You just